Imagine the universe as a vast, dark ocean. An ocean so immense that it stretches beyond our comprehension, filled with mysteries and wonders. We often think of it as empty space, a void with nothing but darkness, but it's not. It's teeming with invisible waves. These are electromagnetic waves, constantly moving and interacting. They carry energy and information, bridging the gaps between stars and planets, and even between our devices. Light is an electromagnetic wave. Radio waves are too. They are part of the same family, yet they serve different purposes. They are all around us, invisible but ever present, enabling our modern conveniences. These waves travel at the speed of light. That's incredibly fast, about 300,000 kilometers per second. They come in different frequencies and wavelengths, each with unique characteristics. Frequency tells us how many waves pass a point in a second. Higher frequencies mean more waves in a given time. Wavelength is the distance between two wave crests. Longer wavelengths mean fewer waves in a given distance. Different frequencies and wavelengths have different properties, affecting how they interact with the world. We've learned to use these waves, harnessing their power for various applications. We use them for communication, connecting people across the globe. We use them for entertainment, bringing stories and information into our homes. We use them for medicine, allowing us to see inside the human body without surgery. They are essential to our modern world, making our lives more connected and efficient. But this electromagnetic ocean can get choppy, with waves sometimes clashing and causing interference. Just like waves in the sea, electromagnetic waves can interfere with each other, creating complex patterns and sometimes disrupting signals. Electromagnetic interference, or EMI, is like the static on a radio. It's unwanted noise or disturbance in an electrical circuit or signal. It occurs when different electromagnetic waves clash. These clashes can disrupt or degrade the performance of electronic devices. They can even cause them to malfunction. EMI is all about energy. Electromagnetic waves carry energy. When these waves encounter an antenna or a circuit, they can transfer some of their energy. This can create unwanted currents and voltages. These unwanted signals are the essence of EMI. Think of a crowded room full of people talking. It's hard to hear someone clearly. That's because the sound waves from different conversations are interfering with each other. EMI is similar, but with electromagnetic waves instead of sound waves. EMI can affect a wide range of electronic devices. Anything with electrical circuits is vulnerable. This includes smartphones, computers, televisions, and even cars. EMI can cause a variety of problems. It can create noise in audio systems. It can distort images on screens. In more severe cases, EMI can cause devices to malfunction. It can interfere with communication systems. Imagine a plane's navigation system being disrupted by EMI, or a medical device malfunctioning during surgery. The consequences can be serious. EMI can come from natural and human-made sources. Lightning is a natural source of EMI. It produces a powerful burst of electromagnetic energy. Man-made sources include power lines, motors, and electronic devices themselves. As we become more reliant on technology, understanding and managing EMI is increasingly important. To ensure that electronic devices can coexist without interfering with each other, we conduct EMI testing. This process is crucial in our increasingly connected world where countless devices operate simultaneously. It's like a quality control check for electromagnetic compatibility. Just as we ensure products meet safety standards, we also need to ensure they meet electromagnetic standards. We want to make sure that devices can function properly in the presence of other electromagnetic signals. This is essential for the seamless operation of our gadgets, from smartphones to medical equipment. And we want to make sure they don't emit too much electromagnetic noise themselves. Excessive emissions can cause interference, leading to malfunctions in other devices. Think of it like this. Imagine a city with no traffic rules. Without regulations, chaos would ensue, making it impossible for anyone to get anywhere safely. Cars would be crashing into each other everywhere. Similarly, without EMI testing, electronic devices would interfere with each other, causing widespread issues. EMI testing is like establishing traffic rules for the electromagnetic spectrum. It sets the guidelines for how devices should behave to avoid conflicts. It helps to prevent electronic accidents. By adhering to these rules, we ensure that our devices can operate safely and efficiently. There are various types of EMI tests. Each one is designed to address specific aspects of electromagnetic compatibility. Each test focuses on a different aspect of electromagnetic compatibility. Some tests look at emissions, while others examine susceptibility to interference. Some tests measure how much EMI a device emits. This helps us understand the potential impact a device might have on its surroundings. Others test how well a device can withstand EMI from other sources. This ensures that devices remain functional even in environments with high electromagnetic activity. Section 5. Radiated emissions, whispers in the cosmic ocean. Radiated emissions testing looks at the electromagnetic energy that a device emits into the environment through the air. It's like listening for whispers in a vast, quiet room. These whispers are the electromagnetic waves radiating from the device. We want to make sure these whispers aren't too loud. During the test, the device is placed in a special chamber. This chamber is designed to block out external electromagnetic noise. It's like a soundproof booth for electromagnetic waves. The device is then turned on, and sensitive antennas measure the strength of the electromagnetic waves it emits. The measurements are compared to established limits. If the emissions are too high, the device may need to be redesigned. Section 6. Conducted emissions, unwanted currents on the information superhighway. Conducted emissions testing examines the electromagnetic energy that a device sends out through its power and signal cables. Think of these cables as information superhighways. We want to make sure that unwanted currents aren't leaking out onto these highways. During the test, special sensors are attached to the device's cables. These sensors act like traffic cameras on the information superhighway. They detect any unwanted currents that are flowing along the cables. Again, the measurements are compared to limits. If the emissions are too high, the device may need better shielding or filtering. Section 7. Immunity testing, building resilience against the electromagnetic storm. Immunity testing is like a stress test for electronic devices. It assesses how well a device can withstand electromagnetic energy from external sources. Imagine subjecting the device to a controlled electromagnetic storm. We want to make sure it can weather the storm without malfunctioning. The device is exposed to high levels of electromagnetic energy at various frequencies. This simulates the real-world electromagnetic environment. The device's performance is closely monitored during the test. If it malfunctions or its performance degrades, it may need to be redesigned to be more resilient. Section 8. Real-world implications from smartphones to spacecraft. EMI and EMC testing are crucial for a wide range of applications. From the smartphones in our pockets to the spacecraft exploring the cosmos, ensuring electromagnetic compatibility is essential. Consider the potential consequences of EMI in different scenarios. A smartphone malfunctioning due to EMI could result in dropped calls, data loss, or even damage to the device. In an aircraft, EMI could interfere with critical navigation and communication systems, jeopardizing the safety of the passengers and crew. In medical devices, EMI could lead to inaccurate readings or malfunctioning equipment, potentially putting patients at risk. Section 9. Ensuring harmony in the electromagnetic spectrum. As we venture further into the digital age, our reliance on electronic devices will only grow. From smartphones to laptops and from tablets to smartwatches, these devices have become integral to our daily lives. They connect us, entertain us, and even help us manage our health and well-being. The electromagnetic spectrum is a shared resource. It encompasses all the frequencies of electromagnetic radiation, from radio waves to gamma rays. Each frequency band has its own unique applications and users, making it a vital part of our technological ecosystem. It's like a vast park where everyone wants to have a picnic. Just as people need space to enjoy their activities without disturbing others, devices need their own frequencies to operate without causing interference. EMI and EMC testing help to ensure that everyone can enjoy the park without interfering with each other's enjoyment. These tests are crucial for identifying and mitigating potential sources of electromagnetic interference, ensuring that devices can coexist peacefully. By understanding and managing EMI, we can foster harmony in the electromagnetic spectrum. This involves not only testing, but also designing devices with electromagnetic compatibility in mind, ensuring they can function properly in their intended environments. This will pave the way for continued technological innovation and improve the safety and reliability of the electronic devices that have become indispensable to our modern lives. From medical equipment that saves lives to communication devices that keep us connected, the importance of maintaining harmony in the electromagnetic spectrum cannot be overstated. As we explore the universe within and the universe beyond, let us remember that even in the vastness of space, it's essential to be mindful of our electromagnetic footprint. The choices we make today will shape the technological landscape of tomorrow, ensuring a harmonious coexistence for all.